All right, hello students. This is Mr. Hausneck, and I'll be hosting a series of three different screencasts to review concept already taught in the Forces in Motion unit, as well as to provide some enrichment opportunities in regards to topics we haven't necessarily covered in depth yet. So just as a quick reminder, continue to review those vocab terms. There are 30. You can use all kinds of different methods, Quizlet, StudyMate, any other sources that your teachers are providing you with. So let's get into the review. Basically, I'm just going to go quickly through this and highlight some key points. So when we describe motion, there are three things to consider when describing it. Certainly the object's position, and we always talk about in reference to something else. So we want to make sure we have a point of reference. And stationary objects make really, really good reference points. A little bit later, actually the next slide, I'll talk a little bit about distance versus displacement. We'll do a real quick little word problem to show the difference between distance and displacement. Another thing to consider when describing motion would be the object's speed, or the rate at which it moves, and certainly the direction that it is moving, up, down, left, right, north, south, east, or west. So as I was referring just a moment ago about distance and displacement, when we look at this problem of Kyle running, and you look at the different distances and directions that he is moving, the basic idea here is we want to determine the difference between distance and displacement. So he's going to start here, and as you see, he's going to travel south a certain distance, to the west, to the north, and then finally end at this position to the east. So to calculate the distance, all we want to do is actually add up each segment that he runs. And when you do that, 5.5 plus 3.1 plus 5.5 plus 8 gives you a total distance of 22.1 kilometers. Now, when we actually calculate displacement, all we are really looking at is the distance between where he originally started and where he ended. So here is where he originally started. Here is where he ended. So we are really just looking at this distance here. And if you know he traveled 3.1 kilometers to the west, when we use that reference point from here to here, then all we have to do is take 3.1 from 8, and that gives us actually 4.9. So we know the distance that he was displaced from this point to his ending point is 4.9 kilometers. And it's very important to include a direction because he has now displaced himself to the east of his original position. Moving on, when we look at velocity and acceleration, velocity describes the speed and direction of an object's motion. We can calculate that by dividing distance divided by time. Acceleration describes an object's velocity over time, and any change in speed or direction is considered to be acceleration. If objects have a constant velocity, we say that there is no acceleration there or zero acceleration. If it is speeding up, that's a positive acceleration, and if it's slowing down, we refer to that as negative acceleration. So you can refer back to the Hot Wheels lab where we saw positive and negative acceleration. Just a couple graphs here to show motion through different graphs. We look at these different lines here. You can see a very slow speed because of the slope of line A here, or segment A. And we have to compare that to this segment, which we see a pretty steep slope. Therefore, that shows that we had a little bit faster speed when we compare that to A. And then B and D, you see there is no increase in distance over a certain time. So that means that these particular segments show stationary position. And just a quick review, positive acceleration or speeding up, zero acceleration, where we have just a constant velocity. And then when we are slowing down, that shows us some negative acceleration. So this will conclude the first screencast on describing motion.